Over-engineering in Western tanks and armored fighting vehicles means that they are sometimes made too complicated, expensive or hard to maintain, more than what's really needed for them to do their job well. Even though Western tanks and AFVs are known for being high-tech, the term over-engineered basically points out that some of their design features go too far. As we all know, there should be a balance between advanced technology, practical use in battle, and how easy they are to keep running. This will basically be a similar video to one I already made about the Soviet and Russian vehicles, where I talk about them being lower in quality and therefore higher in quantity compared to Western tanks. This video will be the exact opposite, where I will talk about Western tanks being too high in quality, which makes them over-engineered and as a result too complicated to use. So hello and welcome and enjoy this video. Tanks and AFVs, especially those built during and after the Cold War, are known for being very complex. This complexity came from an arms race where Western countries needed to keep up with the growing threat from the Soviet Union. The focus on making these vehicles survivable, powerful and well protected led to some of the most advanced tanks in the world. For instance, the M1 Abrams and the Leopard 2 tanks have composite and reactive armor, very advanced fire control systems and powerful engines, not to forget all the safety features and protection for the crew. But with light also comes dark. Those tanks are hard to transport, expensive to maintain and very costly overall. Now in comparison, Soviet and Russian tank designs like T-72 or T-90 were made to be easy to produce, reliable and ready for large-scale operations. In terms of armor, the M1 Abrams and Leopard 2 tanks use advanced composite armor. This armor, made of multiple layers with ceramic tiles placed inside a metal structure, usually between regular steel and other metal plates. The ceramic materials are very good at stopping shaped charged warheads like RPGs and also blocking kinetic energy penetrators like long rod shells fired by enemy tanks. In the M1 Abrams, the heavy armor version added depleted uranium layers along with the ceramic, which makes it even better at resisting both kinetic and chemical penetrators. This gives the tank very good protection and allows it to handle most anti-tank threats used today, but it also makes the tank much heavier. The M1A2 version of the Abrams weighs about 73 tons, partly because of this armor, compared to the earlier M1 version, which weighed around 60 tons. Extra weight affects the tank's ground pressure, which is the tank's weight divided by the surface area of its tracks. The Abrams has high ground pressure, which can be a problem in places with soft soil or wet ground, where it can easily get stuck. To move an Abrams, especially over long distances, special trucks called heavy equipment transporter systems are needed. This makes transporting the Abrams more difficult compared to the lighter tanks like T-72, which weighed 46.5 tons. The heavy weight of Western tanks also means they need special bridging equipment. For example, the Leopard 2, which weighs around 62 tons, needs bridges like the M3 amphibious rig or the Leg 1 bridge layer, which can handle such heavy loads. In places where the bridges aren't good enough, extra engineering equipment is needed, which adds even more complexity and cost to deploying these tanks. Another thing is the active protection system used on Western tanks. APS uses radar and countermeasures to detect incoming projectiles like RPG rockets, for example, and then fires a small explosive to destroy or deflect them in the air. It's very effective, as we've seen by Israeli Merkava tanks in Gaza. But the system adds weight, needs to be well integrated with the tank's electronics, and requires regular maintenance for it to work in the first place. During US Army exercises, there were issues with the trophy APS like problems due to a lack of spare parts and difficulties with electronic calibration, which shows how much it depends on high maintenance and precision. On the other hand, Russian systems like Contact 5 or Relict reactive armor use simpler methods with fewer electronics, which makes them better for low maintenance conditions. A gas turbine engine in the M1 Abrams is also a key part of the tank's design, but also a big drawback. The gas turbine uses around 10 gallons of fuel per hour when idling and 60 gallons per hour in combat, which is much more than similar diesel engine. During operations like Desert Storm, the Abrams often needed frequent refueling even with its 500-gallon fuel tank, which made keeping it supplied with fuel a top priority. In Iraq, the long supply lines for fuel and parts became a big weakness. Convoys carrying fuel were often attacked by insurgents, which led to major delays and risks. The need for a constant fuel supply shows that the engine wasn't good for long operations without strong logistical support. This issue is less of a problem for simpler diesel-powered tanks like the Russian T-90. Now, I'm not saying that a T-90 does need to be refueled. It has to regularly get refueled too, but just a lot less often depending on the situation. The engine is also more sensitive to dust and sand, which means more maintenance is needed in deserts like those in Iraq and Afghanistan. The US Army even had to use filter cleaning systems and extra filter kits to handle this issue, which added more logistical work. Maintenance crews often had to change filters every few days, while diesel tanks could go longer without needing this kind of work. In urban operations in cities like Baghdad and Fallujah, the Abrams weight and size became a problem. Moving through narrow streets and fighting fast-moving insurgents in city battles shows the downsides of its large size and heavy weight, which made it vulnerable to the damage from IEDs. Insurgents changed their tactics to attack the less armored bottom of the tank, which again asked for repairs and maintenance in a constant pace. British Challenger 2 has one of the most advanced fire control systems among Western tanks called TOX-2, which is a thermal observation and gunnery system. This system helps the gunner find and attack targets effectively, day or night, even in bad weather. It uses an infrared sight, a laser rangefinder, and a digital fire control computer, which works together to give good accuracy even over 5 kilometers away. However, the system's complexity has caused problems in tougher environments. During British operations in Basra, maintenance teams often had to replace or recalibrate the laser rangefinder, which could get misaligned from the bumps and shocks of rough terrain. These advanced optics are also more easily affected by dust, sand, and accidental hits compared to simpler systems. Each TOX unit needs a skilled technician for adjustments, which makes maintenance on the front lines more difficult. Challenger 2 also faced challenges during operation in the 2003 invasion of Iraq in Basra. The Challenger 2 has very good armor called Dorchester Level 2, but this level of protection came with some drawbacks. Reports from the British Army showed that the tank often broke down in the extreme heat and sandy conditions in Iraq. Another issue was the Challenger 2's L-30 rifled gun, which was made to fire specific types of ammunition like high-explosive squash head rounds. The need for these special ammo types made resupply harder, especially in fast-moving or unconventional battles. In contrast, many modern tanks use smoothbore guns that can fire a wider range of NATO standard ammo, which makes logistics easier. The Inter-Vehicle Information System in the Abrams is another example of over-engineering. AFVs lets tank commanders share data about enemy positions, engage enemy targets faster, and navigate using GPS and digital maps. This gives a big advantage for coordinating tactics, but it has some downsides. In areas with poor satellite or radio communication like the mountains in Afghanistan, the system can't be fully used. If the connection fails or is lost, the crew might lose effective communication, which can reduce their awareness of what's happening on the battlefield. Relying on digital communication and data sharing has sometimes made things harder, especially when jamming or tough terrain affects GPS signals. In contrast, Russian tanks used a basic old-school R173 radio system for voice communication, which helps them avoid some of these problems. The improved Bradley acquisition subsystem with its advanced thermal sights and digital targeting improves the Bradley's ability to hit enemy tanks from over 3,750 meters away. However, the system needs a lot of maintenance as well. During Operation Iraqi Freedom, the optics housing on the IBES was often damaged by sandstorm and rough travel across the country. The line-replaceable units had to be swapped out frequently, but spare parts weren't always available, which caused delays. Tanks like the M1 Abrams are heavy, need special fuel, and require a lot of maintenance, which means they work best when there's a strong supply chain to support them. During the Gulf War in 1991, the US military's broad logistics could handle these complex tanks well. But in more difficult environments like in Iraq and Afghanistan, the high maintenance demands of these tanks often put a strain on how well they could operate. In Iraq, for example, the complexity of Western armor often led to downtimes for repairs and upgrades. In urban or asymmetrical warfare, the heavy and bulky design of these vehicles could be a problem when moving through narrow streets or dealing with IEDs. The Bradley fighting vehicle is another example. It was originally designed as an infantry fighting vehicle but got many upgrades in armored electronics which made it much heavier and changed its role from what was first planned. Whether Western tanks and AFVs are over-engineered depends a lot on the situation. In intense battles against equal opponents, the advanced features of Western vehicles gives them a big advantage in protection and firepower. But in asymmetric warfare, urban areas or places with tough supply lines, their complexity and high maintenance needs can become a problem. The debate about over-engineering comes down to trade-offs. Western tanks are built for top-notch technology and battlefield dominance, but their complexity needs a lot of logistical support. This can make them less practical in some combat situations, which raises questions about their cost-effectiveness and usefulness in modern warfare. It's safe to say that if the US gets in a war with an enemy who by chance completely obliterates the US supply lines and logistics, they're cooked. Anyways, that was all I had to say for today's video. I hope you enjoyed it. If you think I said anything that is not right or you think I should have added any additional information to this video, please let me know in the comments and share your knowledge. Besides that, thanks for watching and I'll see you in the next video.